Hey everybody, this is the overview video for 9.4 and 9.5. This is where we learn acid naming. Now remember, I told you earlier, and you may not remember, I guess, but you need to know your anion names, all of your polyatomic flashcards, and your simple monatomic anion names in order to name acids correctly. So please don't forget the names of those polyatomic ions. Now, generic formula for an acid is HNX. X is some kind of anion, and then you have the number of hydrogens in front of it that match its charge. So if X has a -1 charge, you'll have HX. If X has a -2 charge, you'd have H2X. So some kind of hydrogen with an anion. The only exception here is if X was oxygen, it would not be an acid. So X cannot be oxygen, but it can be a polyatomic ion or a single monatomic anion. Okay. All right. There's 3 different naming systems for acids because there's 3 different types of anions. We have anions that end in "ide," I-D-E. We have anions that end in "ite," I-T-E. And we have anions that end in "ate," A-T-E. And all 3 of those have a different naming system for acids, okay? So first, we came up with some memory tricks. Not me personally, but we have memory tricks to help us remember this. The first one, I would like you to write somewhere in this first box, my ride has hydraulics. My ride has hydraulics. And I purposefully spelled hydraulics incorrectly because we are going to use this spelling when we name our acid. So what we do is we have my ride has hydraulics. And what you're going to do is you're going to insert the root name of your element in between hydro and ic. So right here, chloride ends in "ide." So it's going to become hydrochloric acid. Okay, so you put chlor in between hydro and ic, hydrochloric acid. So anything that ends in "ide, you take the root name of the element and you insert it in between hydro and ic, and you add the word acid, and you get your acid name. So again, my ride has hydraulics is how we remember that "ide" becomes hydroic, hydrochloric acid. One nice thing about acids is they all end in acid. So if I ask you to name an acid on the quiz and you put acid at the end of it, you're going to get some points, whether you get the first part right or not. Okay. At the top of the next page, we have ite. Okay. The example is sulfite with hydrogen. Okay. The memory trick is Sprite is delicious. So ite is going to change into us. Now, this is a little bit simpler than the previous one. I'm not inserting sulf in between 2 things. I'm just changing the ending of sulfite to us. Now, if you wrote sulfurous acid, I would give you full credit because you're following our rules, okay? But with sulfur, we do add the UR back on, sulfurous acid, okay? But the us comes from ite. Sprite is delicious. Sulfurous acid. Again, sulfur coming from that. The ite piece, we memorize that SO3 is sulfite. We change sulfite to sulfurous acid. And then the final type was ate. We know that NO3 is nitrate. Nitrate. Well, the memory trick for this one is I ate something icky. I ate something icky. So nitrate becomes nitric acid. Again, it's still NITR because nitrate, nitric, same element, but ate becomes ick. I ate something icky, nitric acid. We'll practice with those, and you'll see a couple of them on your quiz. So please don't stress about acids. Okay. Bases. You could write BOHN or MOHN as a generic formula for a base. Usually if we write B, we mean B for base, not B for boron. That's why that one's sometimes confusing, is because we do have an element B. You could write M for metal. MOH would be a metal hydroxide, okay? And again, N is the number of hydroxides. If that's a 1, the parentheses go away and you just have, MOH or BOH. If your metal has a +2 charge, you're going to have MOH2. If your metal has a +3 charge, it'll be MOH3. So whatever that N is the charge of that metal. They're named exactly like ionic compounds, so you don't have to worry about a naming system for bases. You just name the metal and then you name the hydroxide. So barium hydroxide, sodium hydroxide, aluminum hydroxide, whatever it is. Finally, I want to talk about pH. You've probably learned this before, but pH is a measure of acidity. So that's our first class notes there. pH is a measure of acidity. And acids and bases are opposite of each other. pH is measured on a scale based around the number 7. So acids have a pH lower than 7. Bases have a pH higher than 7. And neutral things have a pH of 7. Sometimes people come with a misconception that acids have a pH of 1 to 6. That's not true. We can have an acid that has a pH of 6.2 or 6.9. Okay, technically it's still not neutral if it's not 7. Also, we can have acids that have a pH of 0 or a pH of -1. So it's less than 7 is more accurate. And then same thing with bases. It's not just 8 and above. It's anything over 7 is a base. So please fix that in your brain if you came with that misconception. For 9.5, the only thing I want to talk about is that law of definite proportions. It talks about how a compound is going to have the same ratio of masses or same proportion of masses for each element. Another way to say that is you have the same ratio of elements in a given compound. So no matter where water comes from, it can come from the ocean, it can come from the swimming pool, it can come from the toilet, it can come from your pee. It's still 2 hydrogens to 1 oxygen because it's water, and water has to be that ratio or it wouldn't be water. It's basically defining what a compound is, but that is a law of definite proportions, and just want to make sure that you can recognize that. If you have questions on any of the sample problems or lesson check, please make sure you mark those and you bring those questions to class with you. The next time that you see me, you can ask me and get those clarified so that we don't have any misunderstandings or mistakes on the quiz. Thank you, and I hope you have a great day.